The extraction and electrolysis of copper process is an important method for extracting high-purity copper from copper-containing raw materials. The process mainly includes leaching and filtration, extraction system, washing system, re-extraction system, electrolytic system, transfer and regeneration system. The purity of cathode copper obtained by electrolysis can reach more than 99%. The following is a detailed explanation of the flowchart. 1. Leaching and filtration. Send the copper concentrate materials into the leaching tank and add sulfuric acid from the sulfuric acid barrel for the leaching reaction. Sulfuric acid reacts chemically with the copper concentrate, causing the copper elements in the copper concentrate to enter the solution in the form of ions, forming a high copper liquid. During this process, slag is generated. The slag is separated by a filter press and discharged, while the high copper liquid continues to the subsequent processes. 2. Extraction system. The high copper liquid enters the extraction system, and the extractant from the extractant tank is added to the extraction tank. The extractant can selectively combine with copper ions, transferring the copper ions from the aqueous phase to the organic phase, achieving the initial separation of copper from other impurities. After extraction, the raffinate containing impurities is separated, and the copper-loaded organic phase enters the next step. 3. Washing system. The copper-loaded organic phase after extraction enters the washing tank and is cleaned with pure water to remove impurity ions and avoid affecting the subsequent extraction effect. 4. Re-extraction system. After washing, the copper-loaded organic phase enters the extraction tank, where the back extractant is added to make copper ions retransferred to the water phase, forming a copper sulfate solution rich in copper ions. The organic phase after de-extraction can be recycled back to the storage cylinder and transported back to the extraction tank for recycling use, while the water phase containing copper flows into the circulation tank. 5. Electrolytic system. The temperature, concentration, and other parameters of the solution are adjusted in the circulation tank to meet the best conditions of electrolysis. Then the solution flows into the electrolytic cell. Under the action of the current, the copper ions get electrons in the cathode, deposited into the finished copper with higher purity, and the corresponding oxidation reaction occurs in the anode. In the process of electrolysis, the solution is continuously circulated between the circulating tank and the electrolytic cell to maintain the stability of the solution composition and ensure the continuous progress of electrolysis. 6. Transfer and regenerated system. The transfer tank plays the role of buffering and diverting, avoiding the confusion of the whole plant process. The waste liquid from the washing tank will flow to the transfer tank and then return to the washing tank after the recycle water tank. The raffinate from the extraction tank will go into the transfer tank as the regenerated solution and enter the regenerated solution tank. The sub-solution mixing tank will replenish the consumption of chemical agents so that they return to the appropriate state and then enter the sub-solution tank to participate in the subsequent cycle. The copper sulfate solution from the circulation tank is connected to the extraction tank to form a cycle.